For centuries, humankind lived in balance with nature. Over the years, our population, as well as our needs, have expanded. In the process, we have altered the Earth's entire surface and exploited large amounts of its scarce resources. One of the biggest issues confronting our world today is the impact that we, as human beings, have on the planet. From environmental pollution to climate change, human-made activities, such as long-distance traveling, are threatening the Earth's delicate ecosystems and its inhabitants. It is time we ask ourselves, how do we create a future in which both people and nature can thrive? How do we achieve a sustainable existence on Earth while still fulfilling our personal needs? Right now, the world is in desperate need of new technologies. It is up to us to do something unprecedented to change the future. Join us in changing the future of mobility.
Change the future of mobility. Quite an ambitious slogan we've got there. And this evening is partly dedicated to show you what it means to us. But first, hi, my name is Leo.
And I'm Iris.
And today, the two of us are going to guide you through the voyage that kind of depicts our last year, full of ingenuity, hard work, incredible failures, and passionate people who have grown into an amazing team.
During the next hour, you will learn something about who the people are behind Mu0 Hyperloop. You will learn something about what we do and why we do it. We will, of course, present you the results of our hard work, talk a little bit about founding mentality and why it is so important to us. And in the end, we will give you a short outlook what the future might hold for us. After the presentation, you will be kindly invited for our digital get-together. Of course, this would be way nicer to have it in person, but we are pretty convinced that it will be still a nice evening. So use the chance, get to know us, and have fun.
Absolutely. You should not miss out on that one. But now we have sent out a lot of invitations. And given that fact, we should have a very mixed audience today. First and foremost, we would like to welcome our very dedicated and supportive partners, without whom none of this would have been possible. Secondly, we would like to welcome the friends and families of our beloved team members who are joining us now from around the world. And speaking about the world, we also invited Hyperloop teams from around the globe to join us in this special event. Last but not least, we also want to welcome just the interested travelers, students and other people who are just keen to see what we have achieved throughout the last year.
As we have this mixed audience, we are very, very curious to know where you all come from. For that, we prepared a little Slido survey for that. In case you're not familiar with a Slido, no problem at all. It is a tool for interaction, for virtual interaction. So you just have to follow the QR code, or the description. In the description is our link as well. And then you will be redirected to Slido. And so please feel free to answer this question. We are very excited about the answers because we hope to have a very international audience right now. First of all, our team is very international. And secondly, as Leo has already said, we hope to have a lot of Hyperloop groups from all over the world. Oh, look at that.
Oh, we get the first answers. And of course, we have a lot from Karlsruhe, Zurich, very nice. Freiburg, very interesting. And I actually, in the beginning, I saw someone from Mumbai.
Wow.
That is quite a commitment, should be.
It should be in the middle of the night, I guess.
Something like that, very interesting. A lot of people from Karlsruhe, Munich. Ooh. We hope to see you guys, that's very cool.
Cool.
Eppingen.
We will be there in August for testing our pod, right?
Absolutely,
We're looking
and
forward
also
to this.
Valencia, Caracas.
Nice.
That is incredible. All right, so you see, we have not only a very mixed audience, but it's also very, very international. That's also the reason why we speak English today. But we have one wish for this evening, one desire. We hope that after today, you have either learned something new, that you got inspired in some way, or that you saw something that charmed or fascinated you. Now, enough talking for our introduction. We are Mu0 Hyperloop, and this is our story. One of the major issues that we see in transport currently is basically air travel. In 2019, 4.5 billion people have traveled with airplanes. And these numbers have risen throughout the years. This is a huge problem because airplanes are one of the most polluting means of transport. And this is something that we wanted to change with the Hyperloop concept. So the Hyperloop is essentially a train that levitates through a partly evacuated tube close to supersonic speeds. And this system enables very high velocities and at the same time a very good energy efficiency because there is basically a very low air pressure and therefore no air resistance or very low air resistance and almost no rolling resistance due to the levitation of this train. We've seen maglev trains all over in Asia, for example, but also in Germany back in the 1970s. And this is basically what we're trying to revive here, but with a tube around it with no air inside.
The first idea for vacuum transport was in the early 20th century. And then Elon Musk motivated and introduced this concept again with the wording Hyperloop in 2013 with a white paper.
The Hyperloop concept combines the advantages of air travel and train travel. It's as fast as an airplane, but as energy efficient as a train. And this makes the whole concept sustainable and energy efficient.
Yeah, and of course you need energy, but when you combine the Hyperloop system with some solar cells, you have a really environmental friendly system.
So essentially, the Hyperloop is an end-to-end connection intracontinentally between very big cities in Europe. So you could travel, for example, from Paris to Berlin in just an hour. And this is amazing about the technology.
Mu0 Hyperloop wants to focus on two different domains. On the one hand, that's the research on Hyperloop systems. On the other hand, we are engineering a whole prototype for a Hyperloop capsule that includes the electronics, the mechanics, but also the propulsion systems.
It's also very important to take into account there's lots of other things around that have to be done. For example, the marketing, the whole HR topics, and also the management and the project plan have to be done.
We're a team of almost 60 students working on cutting-edge technology to shape the future of mobility.
We have a very skilled and a very motivated team, but of course, we rely on very important partners, and we are so pleased to have lots of very skilled and lots of very motivated teams and professional partners around us. And they are supporting us with knowledge, with money, with funding.
One example is that we're working right now here at the Zeiss Innovation Hub at KIT, and we're very proud and pleased to be able to do our everyday work here. What makes this endeavor so highly interactive is the exchange of ideas and experiences with other student teams all over the world. The ultimate goal for us is then to participate in the European Hyperloop Week in Valencia this year as the only German team.
The cost of a Hyperloop infrastructure will be very high. For this reason, we want to collaborate with locals, politicians, and also construction companies to figure some solutions out and to build a full-scale prototype and a full-scale concept in the future.
We are pretty sure that Hyperloop will see implementation throughout the next decades because it closes a gap that is fundamentally right now. I'm pretty sure that by the year of 2035 we will see a real implementation of the Hyperloop system. Well, I think we now got a pretty good overview about the general Hyperloop concept, the underlying problem it tries to solve, and our basic goals as a student-led initiative. Maybe one quick disclaimer. Whenever we say the word pod, we actually refer to the Hyperloop prototype, the train where people sit in. This is called a pod. Now, 8 years have passed since Elon Musk kind of reintroduced the idea of vacuum transport. And you might wonder, what has happened since then? I can assure you a lot. Actually, so much that it would be way too much to mention all of these points. So we will just start with the end of 2020, with the 8th of November, to be quite frank. Because there, Virgin Hyperloop conducted the very first human passenger transport with the Hyperloop system, showing that it is safe to operate and people can actually travel in a near vacuum environment. And only 3 days later, the Korean Railroad Research Institute, by the way, try to say that 3 times as fast as you can, the Korean Railroad Research Institute announced that they had been able to push one of their 1:17 downscaled prototypes to a velocity of 1,000 kilometers per hour. A record, and pretty impressive as well, I'd say. Now, enough of the general concept. Now we want to know a little bit about Mu0 history. And for that, I ask you to travel back in time with me to the year 2019, when life was a little bit easier and there was a little bit less pandemic. We want to see Olaf, we have seen him already, one of our founders, head of technology, and me, because we in the evenings were sitting on a dinner table in our flat for our internships, and we were talking about God and the world. I'd always been interested and fascinated by magnetically levitating trains, and I had heard of the so-called SpaceX Hyperloop pod competition, where student teams from all over the world participated and showed their Hyperloop prototypes. And I'd always been kind of jealous because I also wanted to take part, and I had thought about switching universities and joining the Hyperloop team in Munich. And I told Olaf one evening, and he said, no, why not try and build something alike in Karlsruhe and see what it leads us to? And we put quite fair bit of thought into that, but eventually our internships would end. Olaf went to Hamburg, I went to Japan, and when we met again a few months later, we had dinner again. And I vividly remember the Caesar salad I ate that evening, because when I finished, Olaf looked at me and he just asked, do we do it? And he didn't even mention the word Hyperloop, but I immediately knew what he was talking about. And we both started to laugh because we kind of felt like we were building something big. And that's how everything began. But we of course knew that we couldn't possibly hope to build all that just the two of us. We needed more insane people willing to kickstart such an ambitious project. So we pitched the idea to some of our friends from work, from scholarships, and other student initiatives. And they were sold from the first moment. Actually, here you can see an image of the first 7 who signed the association statutes to become a registered non-profit organization. What can I say? We had huge goals.
So it was our goal to build a fully functioning Hyperloop prototype within less than 10 months. With this prototype, we wanted to take part in international competitions. One of these international competitions is the European Hyperloop Week, or EHW. The EHW is a design competition which will take place for the first time this year. You might be familiar with the SpaceX Hyperloop pod competitions. They don't take place at the moment right now, but former teams of the SpaceX competition decided to host their own event. And this is why people from all over the world will come to Valencia this year, or this July, to meet there and to compete with their pods. So EHW is not only about the competition, it's also about bringing people together to exchange their ideas and drive innovation forward. We can't wait for EHW to come. It's basically 3 weeks till that. And we hope a lot of other participating Hyperloop teams are watching right now. See you in Valencia, guys.
Absolutely, and I hope you keep pushing your prototypes because we want to see the best out of them. Now, these were indeed huge goals, and in order to get there, in order to achieve those goals, there were several things that had to be taken care of at first. Some of them are pretty obvious. We needed lab access, offices to work in, we needed financial resources, lab equipment, tools, and so many other things that just pop up on your way and that you would have never thought of before. Now, it was particularly difficult during the Corona crisis to acquire all these things, especially because we were a first-year team with nothing physical to show off at that point. And that is exactly why we are so happy and so proud that so many of our partners decided to support us and that they believed in our vision and in our spirit to keep pushing. But still, we were missing on one thing, and that was a team.
Starting in May 2020, with only 7 people, we have multiplied tenfold by now. Right now, we are 60 members who have worked hard during the last couple of months. We have been originally founded at Karlsruhe Institute of Technology, but we have expanded to more universities. So we are especially proud of our cooperation with University Stuttgart, as we want to set up our second location there in the future. And we are so looking forward for our first members to join in from Stuttgart. And what I really love about our team is that it's very international. We basically come from all over the world, having 16 different nations here. And we are also quite interdisciplinary. We have fields of studies ranging from mechanical, electrical, industrial engineering, mechatronics, computer science. We have aerospace engineering, media design, physics, and so many more. For us, it's really the team what makes Mu0 such a special and unique experience. And during the last couple of months, we have grown into a little Mu0 family. And therefore, it's just so sad that our whole team can't be here today and celebrate this special moment with us together. But we really want to say thank you to all our team members. It was an awesome journey with you, and we are so honored to have you and shape the future with you together. But I would say, enough talking. We brought a little video showing what it's like to be part of Mu0 Hyperloop.
I'm one of the founders of Mu0 Hyperloop, and I saw the opportunity to create something completely new, something with substance, and the opportunity to work with people with an incredible willing.
When Olaf and Leo told me they wanted to found Mu0 Hyperloop, there was no question whether to join them or not.
I was very hyped from the beginning.
Coming from the aviation industry, I'm very aware of the passenger growth at airports and the resulting capacity constraints. So I was very interested in the Hyperloop as a sustainable substitute for short-haul flights.
To me, it felt like a once-in-a-lifetime opportunity. I had the honor to lead a team of about 20 people, and when do you have this chance?
Skills which are not taught at uni, but you can learn them at such student groups as Mu0, and it really helps you later in the job get your work done.
So from the tools, I got to do 3D printing again. I haven't 3D printed in a very long time. What's exciting is that we can be very flexible with it, so we can change the design last second and still have the capacity to manufacture in-house.
What makes it fun is just the people at Mu0. It's just fun to work with them.
We talk a lot to each other, have a lot of team building, even with the digital work.
And when I had the chance to join Mu0, I just had to take this opportunity.
We have grown into a little Mu0 family. It's so much fun working with all these people.
I learned to work together with people with completely different background and knowledge set.
We have people from different fields of studies, cities or even countries.
We welcome everyone, it doesn't matter what background you have.
There were quite some astonished and thrilled people who couldn't believe what we have achieved in such a short period of time. And of course, that's a great confirmation for the hard work we are putting in the project, and also it motivates us to keep going.
We are a bunch of open-minded,
international,
ambitious,
focused,
hardworking,
funny,
diverse,
familiar,
friendly, and just amazing
students who work on a common goal.
building the Hyperloop prototype.
Although I have seen that video about 50 times before, I still love watching it because it just reminds me of how much fun it is to have these people around. For example, a fun fact of us is that we have our own division cup. Our division cup is very similar to the house cup of Harry Potter, meaning that every division can gain points there if they do some good stuff, but they can also lose points if they do some bad things. At the end of the season, there will be some kind of ceremony where the winner will be crowned and the loser gets punished. So let's have a look at the divisions and the status of the Division Cup. First of all, we have 5 divisions One is overall system and strategy, which is our board, and then we have 4 operating ones. The business and operations division, and 3 technical ones, ranging from the mechanics, the electronics, and the propulsion system. And wait, I really don't know why, but my business operations division is on the last place at the Division Cup. How can that actually be? Okay, so I really don't know, and I really don't want to go to the Forbidden Forest or anything like that. But I think there's still some time to catch up. Maybe I should have a look at the technical divisions and what they're doing right now. So I hand over to Leo again.
Yeah, I just saw that also the board could do a little bit better. Maybe we should put a little bit more work into the project. I don't know. But actually, at the EHW, there is a design competition. And this design competition is divided into 6 different award categories. We have one for levitation, propulsion, electronics, mechanics, one for the overall pod, and one for full scale. We applied to all of these award categories except for the full scale one, because we first wanted to get basic experience and knowledge about our systems and our concepts before we try to scale them up. Now, the cool thing about EHW is that it tries to encourage new ideas, innovation, and research. And that is also the reason why, even though we were a first-year team, we really wanted to try something new in each division, be it a new method, a new concept, or any other kind of new idea. And how that exactly turned out will now tell you our 3 technical division leaders.
Let's start with our engineering guidelines. As a first-season team, we did not strive for velocities of 300 kilometers per hour. Instead, we wanted to focus on technology for specific components that could be relevant for future Hyperloop developments. Our goal was to build up a fully functioning prototype which is able to achieve about 50 kilometers per hour on a 150 meters test track. All of our designs were inspired by the guideline to build up a modular, a scalable, and an inherently safe system. The framework for our pod design is the passive rail that is made out of aluminium and that was originally developed for the SpaceX Hyperloop pod competition. Instead of using a traction-based propulsion mechanism, we developed a linear induction motor that allows for contact-free force generation. The linear induction motor can be considered as an asynchronous machine that is rolled out flat. And in our system, the stator is placed inside the pod, while the track acts as the rotor. The linear induction motor is designed in a single-sided configuration. That means the moving magnetic fields which are generated by the motor induce a force in the top part of the rail. And in that way, the linear induction motor can not only provide a propulsion and a braking force, but also a levitation force in one single component. Here, levitation is achieved by repulsive forces between the rotor and the stator. That means between the rail and the pod. The levitation and the propulsion forces can be controlled and varied by the motor control system. After literature research and extensive FEM simulations, we built up a first small prototype to validate our concepts. Before the final linear induction motor with a total length of about 130 centimeters was manufactured. With that system, we are able to gain a lot of experience in the development and the manufacturing of linear induction motors and the operation of electrodynamic suspension systems. This can be used in future seasons to further develop levitation and propulsion systems. To test the motor characteristics, so the electrical and the mechanic behavior, we developed the dynamic test bench. The dynamic test bench is also used to validate our motor control and the brake system.
To allow for stable and safe drive, the pod is furthermore equipped with 2 different suspension systems, constraining 5 of 6 degrees of freedom, allowing it to drive straightly forward. One suspension system, the horizontal one, is employed by 4 lateral control modules, who are mounted and pressing against the vertical part of the rail. Furthermore, we have a normal vertical suspension system similar to those in cars that allow to adjust the air gap between the motor and the rail, the upper surface. Also, they act as a normal suspension system at low speeds and for stationary tests. To further add security to the system, we have a redundant brake system that's built on top of the braking capabilities of the linear induction motor. Those 4 emergency brake modules are mounted in front and back of the pod. they are pneumatically actuated, and to further make them more efficient, we developed a wedge mechanism that allows us to use the kinetic energy of the pod to employ the brakes, reducing the actuator forces needed to do so. Actually, we can apply a combined clamping force of over 80 kilonewtons. That's about the weight force of 3 male elephants. The system is fully normally closed, allowing it to actuate even under the loss of electrical power. Making 2 modules a system and making them completely independent, we are able to have a redundant system where each of the 2 systems can break the pod safely down. Actually, safety is one of the biggest concerns for the design of each component, and you can see that it's applied everywhere.
To ensure a safe operation of the powertrain and all high voltage systems, we complied with industrial and automotive standards in all our designs. The LP² division was responsible for all powertrain systems, including the motor and the inverter and the high voltage battery, which provides the energy. The motor control system controls the power flow from the battery to the motor and selects the operation points to follow a specified velocity profile. While the hardware platform and basic software functionalities were provided, we developed further control algorithms and the electronics for safe interaction with the high voltage battery. For the power electronics, a closed-loop cooling liquid system is used. The battery is probably the component where the most team members were involved in, at least for a component in the LP² division. Starting with the simulations of the motor, we derived the high power requirements for the battery, we select an appropriate cell type and the cell configuration using a virtual model of the cell. While the battery management system is a board solution, all other components of the battery were designed and assembled by us. To ensure that the system is modular and can be manufactured rather easily by us, we are using fire-retardant 3D printed battery segment holders. At the end, the battery provides the high power to propel our pod. With 280 cells, the maximum system voltage is 588 volts, and we get a maximum power of 55 kilowatt. That's actually almost the power of a smart EQ. The high voltage battery stores the energy for several dynamic pod runs, with a total capacity of 4.7 kilowatt hours.
At the heart of all components are the electronics, the nerve system, and the brain of the pod. Their main task is to gather and share information, process it, and act accordingly to ensure a safe operation of the pod. Over 40 sensors monitor safety-critical signals, for example, the pressure sensors in our emergency brake system or the laser sensors that monitor the levitation height. In addition, more signals, like 8 temperature sensors in our linear induction motor or the vibrations of the pod, are measured and recorded. Those values can be analyzed after a run to improve future component designs. A Kalman filter is used for sensor fusion for our backwards-looking laser sensor, a wheel encoder, an inertial measurement unit, and the navigation aid sensors. In that way, we get a good estimation of the pod's current velocity and traveled distance. Those values are used by the trajectory controller and to make sure that the pod comes to a safe stop before the end of the track is reached. The whole low-voltage system is powered by a 24-volt battery. Its power is distributed to the individual components using smart high-side switches, and they provide overcurrent protection and the ability to control pumps and motors, for example, the cooling pump. All those components were not designed on their own, but having an overall architecture in mind that is suitable to meet the requirements even of future Hyperloop prototypes. Therefore, a highly modular and scalable architecture was designed. Many smaller ECUs, so the electronic control units, are spread throughout the pod and connected over a digital communication bus. In that way, we can reduce the wiring effort and easily add more ECUs later to the bus system. For all our ECUs, we standardized and implemented a common hard and software-based platform that eases us to develop new ECUs and reduces the potential for errors while doing so. Our basic control unit can be extended with many different shield types to provide a specific function, for example, reading sensors, power distribution, or to control the high voltage system. For software, all ECUs run a real-time operating system that makes sure that safety-critical tasks are always executed in time. Our custom CAN0 communication protocol allows different message types to be exchanged between the ECUs. For example, there are real-time data messages, error messages, or parameter data messages. The code for all this communication is automatically generated using a central database. During a run, our web-based telemetry system can be used to monitor the health of the pod. Each person can configure his individual views to analyze a particular component. The telemetry can also be used to change parameters on the ECUs, for example, the target speed for the next run, or to completely update the software of an ECU over the air. In that way, we make sure that our pod software is always up to date.
Last but not least, let's move to the pod's exterior. The whole prototype is encased with a shell-like structure, serving the purpose to make the aerodynamics of the whole system more efficient, as well as securing all the delicate components inside. As the aerodynamics of the Hyperloop are quite unique, modeling them is a huge task. Therefore, we focused on a simulation framework that we developed during the season. At its core, we have a computational fluid dynamics simulation of the pod's exterior, allowing us to estimate the aerodynamic drag that the pod produces and making it, optimizing it for a more efficient run. To ease the computational cost of this procedure, we went for a surrogate modeling approach, replacing the original simulation with a different model. This framework is completely scalable and can be used to optimize the exterior shell, making it the most efficient that it can be. To ease the access of that software, we went for a fully open source setup using the software tool OpenFOAM. As it's one of the biggest components, actually the biggest in the pod, we have to manufacture it lightweight. We have achieved this by using carbon fiber reinforced plastics that build up two different components, a top and lower part of the shell, that we can use to encapsulate the whole pod. To reduce the manufacturing costs, everything is manufactured in-house, which also has the side effect that we can build up knowledge working with structural CFRP parts. The mold for the two parts are actually manufactured in-house as well, with off-the-shelf 3D printers, where we build up the shell molds that we then use to infiltrate and lay up the carbon fiber strands inside. As you can see, for each single component, the focus was not set on making it the most efficient or the most lightweight, but rather to provide a stable and resilient baseline for future seasons, to provide a prototype that we can use in the next years and to achieve designs and developments in regards of Hyperloop. Back to Iris and Leo.
Thanks to the technical division leaders, and now you should be pretty good informed about the concepts of or the components of our prototype. We are very curious what EHW has to say about our components and our prototype. Normally, it's quite difficult for external people to estimate how much workload went into building such a prototype. So for that, we brought a little quiz for you to show you some numbers. We use Slido for that again, so please scan the QR code or go to the link in the YouTube description and take part in our little quiz. So the first question is, how many components do you think have been sold during the last couple of months? So is it A, 4,981, or B, 536, or C, 1,856? We are quite curious about the answers.
Actually, have you sold it?
I have to admit I didn't.
Me neither. Maybe that is the reason why we are doing this presentation. But now we get the first results very quick. There is a short latency between what we are doing and what you see. And almost, wow, more than 100 people have already used the survey. Incredible.
Wow, that's quite nice.
quite even also. Iris, what is the correct answer?
So the correct answer is, and most of you are right, it's 1,856.
Not bad. That is quite a few parts being soldered.
Definitely.
But let's take that a step further. We have another question prepared for you. And the next question is, what is the total number of parts contained in our prototype? Is it A, 2,034, B, 14,679, or C, 320,578? Again, your guess.
I think recently I have found a screw in my pocket. I hope.
Oh, that's where all the screws go. Actually, I think we lost more screws than we actually have parts in this pod. But now we see a pretty clear winner. And more than 100 people have taken the survey. So the correct answer is indeed 14,679. So many parts. And we take into account every screw, every nut, every washer, and every resistor on every electronic board inside of this prototype. Now, try to keep track of each and every one of these parts. That's difficult, I'd say. But we have one more question for you. And this one is quite funny, I think. The question is, how many Microsoft Teams calls did Iris participate in during the last month? Only 1 month. Is it A, 87, B, 247, or C, 132? Again, your guess.
I have to say I didn't know the number as well. So
I didn't even know how to find out. But our technical division leaders, they knew, of course. Use the Microsoft admin panel for that to find out what you've done. And I think we should get the first answers in a second. There we go. This is not as clear as the last one.
So, but I think most of you say it's 247.
Is that correct?
Yeah, I have to say that's correct. And I was very surprised by the answer because I seem to be not to doing anything else than just having Teams calls. But
yeah, but to be honest, the last months have been very intense, especially planning this event here.
Yeah,
so I think that is okay. Now, I think you got a pretty good feeling about how much work goes into these kinds of prototypes. And now I'm pretty sure that you want to know what is under the cloth. And I assure you, we get there. But one thing at a time. We have now seen all the subsystems on their own in the last video, and we cannot, and we also don't want to withhold the beauty of them being assembled. So now we get the last chance to take a look inside of our prototype and to see the technology behind it before it gets enclosed in the beautiful yet kind of merciless carbon fiber reinforced shell for the final pod reveal. And I say merciless because it has not only cost us a lot of work, but also a tremendous amount of 3D printing filament. But I think that is enough talking. Lars, show us.
Thanks, Iris. Thanks, Leo. I guess it's fair to say that a lot of blood, sweat, and tears went into each single component, its design, the concepts, and the manufacturing after all. If you imagine that just 1 year ago, none of this was reality, just blank papers. And now we are actually able to show you a fully functioning Hyperloop prototype. It's just great to see how everything is coming together such nicely. But now, enough talking, let's have a look at the components.
And we are back. And I would really like to know, did you also get goosebumps when the lights turned off and then suddenly the beat kicks in and you see the prototype? Well, it's not the final prototype. As I said, we're still missing on the outer shell. But I hope that you are as excited as we are, because we really cannot wait any longer to reveal that pod. No, that doesn't sound very cool. And we had the exact same thought almost a year ago when we were sitting in the city park, in the castle park in Karlsruhe, and we were thinking about suitable names for a prototype that we hadn't even started building. And of course, someone came up with a very cool idea at some point. And the idea referred to an event that only happens every 6,766 years. Yet, we were alive and we were able to observe it despite the corona crisis. And you might already know what event I'm talking about. Now is the moment that you have been waiting for and that we have been waiting for more than a year. And I think we as a team couldn't be prouder to unveil the very first Mu0 Hyperloop pod prototype. Ladies and gentlemen, please welcome MZHP001, better known as NeoWise.
Whew. Leo, can you imagine how it would be when our whole team was here, standing right behind us with the pod and being proud as anyone could be, and just celebrating this moment with us together? This would be a beautiful imagination, but of course it's not possible right now. And therefore it's just so sad, but we hope that at our next Hyperlaunch in 1 year, we can celebrate this moment together. I'm still so flashed what have happened during the last couple of months. And actually, I can't believe that we're standing here right now presenting the prototype to our world. The last year has been intense, but it was definitely worth it. So, during the last couple of months, the hard work we have done wouldn't have been possible without a very specific group of spectators. Our sponsors. On behalf of our whole team, I would like to say thank you for your great support during the last couple of months, be it financially, idly, or with donations in any kind. Let's say software or furniture, tools, equipment. We even got some beer.
Yeah, and that might actually be one of the most important resources for some of our team members. Well, I can actually see the crate for after the event over there. I hope the cameraman leaves something for us. It is what it is.
I'm looking forward to it. But back to our sponsors. We have also received a lot of support during our manufacturing phase. I especially want to mention Traktionssysteme Austria here, which is one of our platinum sponsors. Together with them, we developed our motor. I would also like to say thank you to Pulse Performance Drives, another platinum sponsor of us. They allowed us to be in their workshops, and together with them, we developed the battery. And last but not least, I would like to say a special thanks to Zeiss Innovation Hub at KIT. Tonight, we have the special chance to host our Hyperlaunch here at this wonderful space, and we are so thankful for that. So, but besides from our sponsors, I would like to announce a very special supporter of us, Frank Thelen. Frank Thelen is a very famous German entrepreneur, and he's also very connected to the Hyperloop topic as he's involved in Hyperloop, which is a company from the Netherlands. And he gave us the honor to record a keynote for us for our Hyperlaunch, and he will talk a little bit about founding mentality and innovative technologies. especially the founding mentality is very important to us, as working at Mu0 is almost like working at a startup. So it actually has all began when Leo wanted to go to Munich, as he told you before, but he decided against it, and it was lucky for us because he and Olaf founded a Hyperloop team there, and that's how all started. And we try to take up this founding mentality, and we try to instill it in all our team members and to encourage them in doing something on their own. Well, I actually can only speak for myself. 1 year ago, I actually could never understand why so many of my fellow students wanted to start a business, something like that. But now, after 1 year working at Mu0, I'm rather like, guys, when do we start our own business? I can't wait for it. And I think that's how a lot of our team members are feeling right now, and therefore we are really looking for the keynote. So enjoy it.
I'm excited to dive with you into the 10x DNA. Definitely something that also powers the Mu0 Hyperloop team. It's an incredible achievement. It's a great product. It's a new dimension for transportation. But now let's dive into the keynote. One very important aspect is to understand exponential development. Our brain is wired to think linear. That's what we have learned and seen over the last couple of years where our brain have been built. But now, based on digitization and the upcoming disruptive technologies, we will see exponential progress. And the tricky thing is, it starts a little bit slower, but then it gets super fast and super progressive. And the good thing is, for the first time in human history, we know already what's coming, because the base technologies have been developed in the labs, in the research, and have seen that they work. And they will now see mass adoption in B2C and B2B products. We call it the 10x Technology Kit. The 10x Technology Kit embraces technologies that already have seen mass adaptation, like internet, cloud, and smartphone. But the next generation, like artificial intelligence, 3D printing, robotics, and many more already have been developed and will now see mass adaptation in the markets. We are in a digital revolution. It all started with the moon landing. So the moon landing, of course, was a very special thing, and it all moved us. But behind the moon landing, there was a very, very smart, big, progressive team that developed most of the basic technologies that then enabled the digital revolution. And what happened is that the chips, internet, and then later the cloud and smartphone created really big companies in a very short period of time. We all know them. We all use their products. Google, Facebook, Amazon. And then in China, because they didn't allow the American products, there have also been big companies like Alibaba, Baidu, Tencent, and many more. And this was the first big step in disruptive technologies triggered by chips, internet, smartphone, and the cloud. The first phase of new disruptive technologies based on the new chips, the internet, the cloud, and the smartphones, we as Europeans have not been utilizing to create meaningful companies. When you look to the US, we all know them. It's called the GAFA, the Google, Apple, Facebook, Amazon, but many more today. They have created a lot of value. And that's why their market capitalization is now so much bigger than, for example, in Germany, the German DAX. And that's because they utilized the new technologies, and also from their products and from the users and their engagement and their value creation, they have seen exponential progress. And this is reflected in the market capitalization of these companies. But the good thing, we already know that there will be a 2.0 era that comes after the digital revolution based on the technologies. And this 2.0 era will utilize the platform that have been created through digitalization, but unique and new disruptive technologies will create even bigger opportunities. And I hope Europe will take the opportunities. Today, we are facing the biggest challenges in human history. Climate change is a really big problem because it's hard to stop what we have done wrong for many, many decades. And climate change we have to solve, because if we don't solve this huge problem, then we're not allowed to play on this beautiful planet. Pollution is a big problem. Of course, CO2 emission leading to climate change, but also plastics and many other things. So we're consuming too much and we're putting too much things that should not be there into our beautiful planet, and pollution is a big, big challenge. And then AI is a great opportunity, but also a challenge, because artificial intelligence can also become a weapon, and it could become the worst weapon we have ever seen. I don't believe it will become this kind of weapon, but we should be aware that this could be the case and that we need to regulate artificial intelligence. When you think about it, what are our options here? We could say we change directions. So through the industrial revolutions and all the cars and planes and big buildings, we say that was the wrong approach. We go back to the cave, we start fishing again, and we become more like one with our planet. But I believe this is no option, because we have been used to great food, traveling, looking great movies, enjoying also a lot of the things that we have been built. So I truly believe we have to utilize technology, because through technology, we can make the energy shift to sustainable energy happen. We can deliver and create food that is sustainable. Through technology, we can even reverse things, like taking CO2 out of the air and building concrete out of it. So technology allows us for many, many great things, and then we can still have the great wine, the great food, the traveling, the movies, all the things that we like, but we have zero footprint. So we don't harm our beautiful planet. After coming to this conclusion, technology is the only way to go forward. I also changed my personal life and my business. I'm a venture capitalist with Freigeist. So we support startups. We give them capital, but also our knowledge, our experience, and build them hopefully in big, thriving companies. And today, Freigeist is focusing on startups that have a positive impact. For example, Lilium Aviation is an airplane with zero emission. It's a vertical takeoff landing jet that is fully electric, super efficient, and we don't need to build more roads, because roads, for example, are one of the biggest sources for CO2 pollution. Or Kraftblock, that's an energy storage built with nanotechnology that can store a lot of energy. So it's very, very efficient, very cheap to build huge storage. And when, for example, we have a lot of wind, we have a lot of sun, but the consumers don't need the energy, we can store it in a very efficient and very environmentally friendly way. It's 80% of recycled material, it's not harming anyone. So that's an energy storage we're creating with Kraftblock. Or Hot Hyperloop. It's a way to travel with 1,400 kilometers per hour, so super fast, even faster than most of the planes available, but it has zero emission. It's a new concept called Hyperloop, hyper efficient traveling, very secure, low total cost of ownership, and the pods like the train wagons today, can stop at more stops without reducing the speed of the whole pot part. And it's important because then you can connect even smaller cities also with fast transportation. So it's important to build new communities for schools and so on. And that's something that also the Hyperloop enables. And there are many, many more projects. Some projects we're not involved yet, like ocean cleanup, lab-grown meat so that you can still eat meat, but you don't have the pollution that we unfortunately see with meat and so on. So there are many good examples, and we're focusing on these founders and unleash them to build products for a better world so that we can basically, have to be honest, be allowed to stay on this planet. If we keep on doing what we do right now, we will not be allowed to stay on this planet. And there are many challenges, like how do you regulate AI? How strong do you force the shift to new energy? There's always cost involved, and there's always have impact on lives, on people. But I truly believe we need 3 strong forces: the US, China, and a strong Europe, to discuss at arm's length the challenges and what is the best way to go forward for all of us, for the whole planet. And that's why I'm fighting for Europe. And that's why I'm building and supporting technology startups in Europe. Because the US and China today are much stronger in these fields than Europe. And I want to have a balance between these 2 strong voices to find the best answers for the challenges that we are facing today. If you want to get an even deeper understanding of the technologies, of the mechanics, of the products behind this 10x revolution, I've written a book, 10x DNA, a mindset for a thriving future. It describes many of the technologies, like the blockchain in depth. So how does it work? How is the network built? AI, what are the latest technologies, all the chips, and also explain things like Moore's law, Wright's law. So what is the thinking, the mechanics behind it? Why is it possible to build, for example, a Tesla in such a short period of time? So 10x DNA is my book explaining these topics. And now it's time to say thank you. A lot of information, many new technologies. Thank you so much for standing with me, opening your mind, learning about new worlds, and I hope you are excited. And this was just a starting point for you to utilize all the possibilities. Thank you very much.
We from Mu0 Hyperloop also want to learn about the new worlds Frank Thelen has just mentioned. Therefore, we do not only want to build a Hyperloop prototype and take part in competitions. We want more. In our next season, we want to do some pioneering work in the whole Hyperloop topic itself. Therefore, we first of all want to establish a simulation framework simulating all our components in order to automate and accelerate the whole development process. We also want to conduct concept studies on topics like the infrastructure, on route planning, but also on finding new business models for the Hyperloop technology. Right now, we are currently working together with a design agency from Stuttgart. They are called Moya Design, and together with us, they depicted how Hyperloop might look like at some day. So, let's have a look into the future with them.
Well, well, well. What can I say? One beautiful video after another. But as beautiful as this video might have been, many thoughts and considerations went into the design process behind it. The main objective that we defined here was to minimize the actual pod diameter to keep the costs for the surrounding vacuum tube as low as possible. But at the same time, we wanted to maximize the experience space inside of the Hyperloop capsule to increase the passenger comfort. And I think Moya did a great job here in dividing the capsule into two segments, one for the business class and one for the economy class, giving it a slight shift in the pathway through the capsule and therefore giving it a bigger and more natural feeling. One noteworthy mention is also that even in the economy class, you got more space than, for example, in an ICE. And I don't know about you, Iris, but I really like traveling in an ICE if it was just a little bit faster. The other thing I really liked about the concept was the autonomous exchange of luggage, because it speeds up the entire boarding and unboarding process and therefore enables very high frequency departures, which is crucial for a functioning Hyperloop system. Now, let's all take a step back and remember how we started this evening. Have you either learned something new? Did you get inspired? Or did you see something that charmed you? Well, if so, I think we have absolutely achieved our goal. And maybe you now also understand a little bit better what changing the future of mobility means to us. Yet, a lot of what we've seen is still the future, but we're making progress, and we're making progress fast. So for now, let's keep the flame burning, let's keep researching, and let's keep innovating. And as this is a Hyperloop keynote, of course, we have to quote Elon Musk at least once. And I want to do so by saying, we need a future that's inspiring, because otherwise, what's the point? And I think these would be very cool words to end the official presentation part of our Hyperlaunch, but we have 3 more announcements to make. The first one, if you are a student and watching right now, and you want to be part of the Mu0 Hyperlaunch journey for next season, you've still got some time left to join us. When is the application deadline again?
It's on 4th of July, so basically this Sunday.
Exactly, and also if you want to know a little bit more about us, you can join us on our last information evening the day after tomorrow, Wednesday, I think.
Yeah, at 7 p.m. we would be looking forward to see a lot of you there.
Exactly. The second announcement, real quick, the KIT Neuland event takes place throughout the next several days, so also check that out if you want to. And the third announcement, the third thing to do for this evening is to thank all the people behind the scenes who have made this incredible event possible. I want to see those guys switch the camera. There they are. You see they are not there. The light comes. Wave your hands. Thanks a lot. I mean, look at the setup. How can you track all the cables? That is incredible. All right, so that is it for the announcements. We now want to slowly transition into the digital get-together. We have prepared a small video for that, but to all of you who are unfortunately not able to join us, we can express nothing but gratitude for being here today with this very special event. We wish you all the best, stay healthy in these turbulent times, and of course we hope to see you for our next Hyperlaunch.
So, for our digital get-together, we will use wonder.me, we have this description video. The link will be at the description of the YouTube live stream. So just click on it, then you will be redirected to Wonder. You just have to follow the instructions, permit the browser requests, choose a camera, and take a nice picture of you.
Nice one, Alex.
Yeah, and then you just have to add your name, and that's basically it. Then you will be redirected to the wonder.me room. At the wonder.me room, there are different areas for our divisions or our different task forces. So if you have a specific question, don't hesitate to go there. Your little icon, you can wander around, and if you approach other people, there will be automatically opened a video chat, and then you can have a nice talk, ask all your questions, and just have fun a little bit. And then you can move to another circle if you like, and ask other questions. One thing, you see the little Mu0 icon. These are people from us, so don't hesitate to approach them and ask all your questions. So that's basically how wonder.me works. We look forward to see a lot of you there. And we wish you a nice evening, and thanks again for watching.
Thank you. Bye.